Should probably turn on Q&A, shouldn't I? Oh, it's disabled. That's interesting. Okay, well, I don't know how to fix that, so we'll just get started. So basically, there's been a lot of talk about ES6 modules lately and what Node, V8, and the browsers are going to be doing. And I'm just going to talk about how you shouldn't be worried. Basically, there's a loader spec out there that a lot of people have been curious if Node will be compatible with, and I'm going to discuss what ES6 modules are and what exactly the loader spec is and why and how we can work with the loader spec safely and maintain backwards compatibility without breaking legacy code. The big stuff. This is going to be a very technical talk, so I'm going to talk about things directly against the spec, but I will do my best to explain them in simple terms. Basically, first thing that we're going to talk about is what is an ES6 module. In the spec, it's made up of two parts. One is the syntax and one is the hooks for people implementing module loaders. So basically, the syntax is going to be what you see in ES6 code with the import and export keywords. And so that's purely syntactical. That doesn't actually perform any actions. So JavaScript doesn't specify exactly what those do. It just provides hooks for other people to implement a module system. And that's really what we care about, the hooks. And so there are three hooks that are really important, and we're going to talk about those. One is parse module, and that's a function that the VM will provide. So V8 actually has to implement this according to the JavaScript specification. Two is a module record type. Once again, V8 must implement this in order to be a JavaScript VM. And lastly is going to be module evaluation, which is a different function that V8 has to provide. So basically, everything starts when we create scripts, and that's going to be coming from parse module. So parse module, basically all it does is take some JavaScript source code and determine a few things about it. It determines what's imported and what is exported, and it's going to create a module record. And module records are just a representation of exactly what a module has exported, as well as what's being imported. And we'll talk about that in a second. So this is what Node already does kind of with a V8 C++ function called V8 script compile, which takes a string of JavaScript and turns it into a script object. And so basically all that is going on with parse module is there's additional information that needs to be provided when we call V8 script compile. And that additional information is a module record when we call compile. And so what is a module record? A module record is something that the JavaScript specification basically states must be present by the VM. So V8 has to implement this, and it needs to have some specific properties on it. One is it needs to have a list of all the requested modules inside the source code. and it needs to have them as strings. So if I do import create server from HTTP, you would get a list with the string HTTP. And it's up to the host environment, node in our case, to determine where to grab HTTP from. The other thing is going to be, it needs to list everything it's going to export if it's an ES6 module. So unlike CommonJS, you can't change what you're exporting. You can't add a new export after your module is evaluated. So you can't do something like set timeout 10 seconds and then suddenly change exports to include a new property. And that's just how the modules work, but they're opt-in. So this actually doesn't break any of the existing CommonJS modules. It doesn't break anything from NPM because this is only your current module. If your module is using the export syntax. So to be clear, although you cannot add exports after your module is evaluated, it is opt-in. And so it's a non-breaking change. While some people may consider that new semantics, that is very much true. This is kind of like using strict mode. If you're using this new feature, you have to learn the new semantics. That being said, there are some nice features about having static guarantees. And we can talk about those if people send me questions. The last thing is going to be module evaluation. So V8 needs to provide one third thing, and that is the ability to evaluate a module and populate the bindings of those modules. So whenever we parse a module, whenever we go and use parse module, it is only parsing the source text. It is not populating the values of any exports. And so there needs to be a hook in V8 that calls module evaluation, which is kind of an oddly named function, that basically states during module evaluation is when we are going to set up our initial values for all of our exports. And this is going to be done after everything is parsed. So basically, once we parse everything, once we have all these module records with lists of what we're going to import and lists of what we're going to export, that is when we can do this. But how does Node do the loading in a little bit more of a procedural manner? Whenever we either require or import a ES6 module, we're going to gather all the module records for an import. That means all the submodules as well. Whenever we encounter an ES6 module, we're going to pre-process all the imports before we evaluate it. So that means it'll gather all the imports for your submodules, their submodules, and so on until it reaches a leaf node and no longer needs to try to resolve more imports. And we want to keep a record of exactly the order in which imports occurred so we can have it be the same as require would do it. There is a little bit of a hiccup here, but it's not a breaking hiccup. If we encounter a module that is not ES6, so something that is not using import or export, we don't actually know what values or properties it's going to export. And so we actually need to immediately evaluate it in order to get those list of things that it's going to export. So when we evaluate it, we're actually going back to step number one. And if that CommonJS module is requiring another module that is ES6, we kind of re-enter this and it's a recursive loop. So yeah. But if we encounter an ES6 module while parsing things, we actually just keep gathering data. We don't evaluate it, we gather the data. And then when we're done gathering all the data for the current import, that is when we run module evaluation. And since we've already evaluated all the common JS modules, we're going to evaluate the ES6 modules then. And this is why it's important to keep a record of the order of imports so we can kind of reorder the exact same structure as would be for common JS when we're doing order of operations, so we can evaluate modules in the same order as requires now. So all these things are going to have new semantics. So by using import or export, you're going to be opting into some changes. Just like how if you use the strict mode, use strict pragma, you opt into some changes. So changes are going to be breaking for new ES6 modules. These will not break in any form or fashion existing NPM modules because it only affects the current module, that is the module using import or export. So what are these semantic changes? One, modules in ES6 are always in strict mode. So if your code is not compatible with strict mode, you may have to change it to be compatible with strict mode. Two, exports cannot be changed by outside modules. We'll go into an example about this in a second. Basically, any ES6 module using the export syntax is guarded against monkey patching. Because of that, and because a lot of people need to be able to monkey patch core, core is actually going to stay on the same semantics as common JS. It's not going to have the exact same semantics as ES6. It'll be the same existing semantics. So only new code in user land will be guarded against monkey patching. Last is going to be circular modules need to be static for ES6 modules. This does not mean that circular modules will break on existing code. Only for ES6 modules will this be true. So an ES6 module must know at the time it is compiled and parsed what it is going to be importing. That said, there is a hiccup we'll get to about that one as well. So let's discuss that exports cannot be changed by outside modules. So say we have two modules. One is outside.js and one is mymodule.js. So mymodule.js is using export syntax to create a list of module exports, and it's going to export two things. One is a counter called calls, and one is a way to increment the counter called call. Basically, when you call, it will increment the counter. And we're going to actually require that on the outside somehow. It could be through import, it could be through require, it doesn't really matter. Basically, when we try to log out what calls is, it's going to be 0 to begin with, and then we're going to increment it, and then it's going to be 1. So we're able to visibly see the changes in the outside, but we can't modify it. So since export is a ES6 module, ES6 modules actually have rules about who's allowed to modify it. And if you try to monkey patch it, in this case, if we try to artificially increment the counter, it'll cause a throw. So that's what's meant by you can't monkey patch it and exports can't be changed by outside modules. The other thing is going to be circular modules have to be static. You have to be able to evaluate what's going to be exported. So if we have a common JS module requiring an ES6 module, the ES6 module will not be able to see the values of a common JS module if it's a circular dependency. That's because when ES6 modules try to see the exports of a circular dependency, the common JS module hasn't finished being evaluated. So its current list of exports is empty. So in this case, it doesn't matter what's in cjs.js. It could export as many things as it wants. However, these will not be visible from the ES6 module if it's a circular dependency. This is not true if ES6 modules were to require other ES6 modules because all their bindings are hooked up before they're evaluated. So what does this really mean? What's the support problem here? Current modules using CommonJS work fine. You can circularly require parents. So if a CommonJS is requiring a parent ES6 module, that's fine. If a CommonJS module is requiring another CommonJS module circularly, that's fine. If an ES6 module is requiring another ES6 module circular, that's fine. The only problem is if an ES6 module is trying to require a parent CommonJS module, it won't be able to see the CommonJS module's exports because the CommonJS module hasn't finished evaluating. And when ES6 is parsing and trying to determine what it is importing from its parent CommonJS module, it doesn't have a list yet because it hasn't finished evaluating. Okay. So in summary again, none of these break existing or legacy code. All of these are going to be, when you use ES6 syntax, import and export, your current module, no submodules, no dependencies, your current module will have some slightly different semantics, and these will be documented and fairly well known. It's pretty easy to detect some of these. I don't know if people write tools, I suspect they will about this, but no legacy code will break, and that's the important thing. So now that we kind of understand a little bit about how ES6 modules work and what they are, really, we're going to talk about what the loader is. And the loader is made by WhatWG, WhatWG, some people say. And it's made up of two things. Just like ES6 modules are made up of two things. One is the registry, and the other is the pipeline. The registry is basically what we think of in node land as require.cache. So what is it? It's a map of strings to what are called module status. And that's just kind of a module object describing the current status of it, what's currently being exported, and things of that nature. But it's an actual compatible with ES6 map. That means it has get, it has set, it has, and a few other things. Semantically, it is the same, so much so, with require.cache. Yeah, so pipeline. The WhatWG loader includes a pipeline, and what the pipeline is the list of exact operations that need to occur between the parse module phase that we talked about earlier and module evaluation. So that's going to be when we were talking about the host needs to resolve what HTTP is. If you import HTTP, it is describing exactly how to find that module. In this case, it is the node modules resolution system of NPM, and we can implement our module resolution algorithm against their pipeline. So although they are creating a pipeline, they are not specifying some things such as how to find files or how exactly to load the source code of those files. It's just listing the steps that need to occur. But their pipeline as it stands currently in their specification uses promises. That is a breaking change if we were to use it. So there is an open issue about speccing out a synchronous pipeline. So the current pipeline in WhatWG's loader is optional. We're not going to use it. We're only going to use the registry, which we can use synchronously in order to maintain backwards compatibility with require. So this is necessary so that there are no changes to existing legacy modules. They act entirely the same. They resolve modules synchronously. They create their exports synchronously without causing any problems. And so to do that, we actually have to implement what is the synchronous pipeline. And so this actually isn't spec'd out in the WhatWG loader, but it's been something that we created an issue on their issue tracker and ensured that there would be compatibility so we can do this without needing to use promises or the micro task queue. Basically, the stages of the pipeline mimic exactly what Node's loader does internally. And so we're just going to recreate their pipeline synchronously instead of an asynchronous proposal. And so how does that work? Well, since the registry is just a map, we can force feed the registry the module entries using registry.set. And so basically we can give it the absolute file path just like in require.cache as the key. And we can give it the module that is created when you do require, just the same as it works right now. That being said, we are working with and talking to WhatWG about including the synchronous pipeline exactly in the WhatWG loader spec. They sound confident that there won't be any problems, as well as we haven't found any problems. All the problems we've had have been removed by them. So, yeah, we're good to go, basically. That's actually all I have for this. And if you have any questions, you may want to provide me with some way to reach out to you. You can use Twitter, you can use other means to contact me. My email is bradley.mech@gmail. On Twitter, I'm Bradley Mech, and I will be looking out for questions, comments, or just general concerns on those. So thank you very much. Okay, bye.